Good afternoon. We will present the project developed in the integrative model, which is design of distribution system to 22 and 36 kilovolts for an area of Guayaquil. The electric utility system is usually divided into three segments, which are generation, transmission, and distribution. The distribution system, which is our main area of interest, is commonly broken down into the following three components: distribution substation, distribution primary, and secondary. In distribution area is where the system is more vulnerable and is exposed to theft, fraud, and other non-technical losses, and is there where the highest level of technical losses is present. Ecuador's electrical infrastructure. In 2014, Ecuador had an installed capacity of 5.7 megawatts, of which 42% were for renewable energy and 58% of non-renewable energy, and the gross energy was almost 25 gigawatts hours. Cost of energy production. To establish an approximation of the value which cost the country produce 1 kilowatt hour, this study will focus on the fuel consumption of the main process of thermoelectric generation, for which three representative companies as refers to thermal generation we're talking: station and feeders. Bien Público substation is located in central area of Guayaquil, between the streets García Moreno and Piedrahíta. The main elements of the substation are a 10 MVA power transformer, 2 gas circuit breaker, 1 triple switch, 2 reclosers, and 600 MVA capacitor bank. Technical characteristics of the feeders. The feeders Quisquis and José Mascote have a radial network topology. The feeder trunks terminating in air switches that are potential points of interconnection with the other feeders. The length of feeder Quisquis is 2.5 kilometers and the feeder José Mascote is 3.1 kilometers. The installed capacity of the feeder Quisquis is 3.6 kilovolts amperes, and the installed capacity of the feeder Mascote is 5.4 kilovolts amperes. Usage regulations. For the 22 kilovolts level was taken as reference the homologation of the property units supported by the Ministry of Electricity and Renewable Energy. And for the 36 kilovolts level was taken as reference the technical standard CRE 004 NT Bolivian Rural Electrification Cooperate. Based on the standards of 22 and 36 kilovolts, the electrical equipment to be replaced are the insulators, capacitor banks, fuse cutout, power rise, reclosers, triple switch, and distribution transformers.
Okay, the next topic is load flow study and economic evaluation. The load flow study was done to meet the electric parameters, and the main objective to know the real value of the electric losses. For the simulation, it was proposed two cases. Case 1, case 2 maximum load, case 2, case 2 minimum load. In the station, it was observed the maximum load was in October 2014, reaching the value of the 60.6 megavolts ampere. In the substation, it was observed that the maximum load was in August 2014, reaching the value of the 3.3 megavolts ampere. The data showed the following power values in the feeders. To the simulation has taken the various load of the substation, which is the 4.8 megavolt ampere, and that is 60% of the rated capacity. You can see the result, the load flow studied for the different level voltage. Load 100%, 38 kV, 22 kV y 36 kV. Economical and finish evaluation. Economic evaluation with the purposes to determine if this project has been feasible to this has used two economic indicators, band and tier. Information economic evaluation. The parameters using the common evaluation were the average inflation rate in Ecuador. The useful lifetime of the project were 30, 40, and 50 years. Project investment. Investment 22 kV, investment 36 kV. Project income. Data show represent saving electrical substation loss and being public that were obtained by changing the level voltage, saving load at 60% and load at 100%. Result economic evaluation case 1, load 60%, load 100%. Conclusion. Nowadays, the substation bien público is working at 60% of the nominal capacity. The chargeability of the 100% is approximately 10 years. Conclusion. Nowadays, the substation bien público is working at 60% of the nominal capacity. This chargeability of the 100% approximately 10 years. With less voltage drop by voltage raise, the grid scope of the feeder will cover with area and thus lead to the half-feeder substation. It was observed that the monetary saving were not as represented as compared the investment required for different voltage levels. Recommendation. The voltage change is strongly discouraged in rural substations due to increased travel of the feeder and lower energy conversion equipment. Note that the high voltage circuits are longer interaction, mean more customer. We should prepare to the worst in advance to change the voltage because it isn't common to deal with this level of the voltage. Thank you.